Today we're going to be learning how to solve a system of equations by a new method called elimination. It's sometimes also known as the addition method. The steps that we're going to follow are number one, we're going to write the system so that like terms are aligned. Number two, eliminate one of the variables and solve for the other variable. Number three, substitute the value of the variable into one of the original equations and solve for the other variable. And then write the answers as an ordered pair, and it is a good idea to check your solution. So let's begin with this first system of equations. 3x minus 4y equals 10, and x plus 4y equals negative 2. Our variables are aligned. X's are over x's and y's are over y's. And notice that if we were to add these equations together, we would get our y's to cancel out. That's what we want. We want one variable to cancel, and that is essentially what's going to happen here. If we added these together, we'd have 4x. Our negative 4y and positive 4y would cancel, and we would end up with 8. We now solve for x, dividing each side by 4, and x would end up being 2. Now, to find out what y is, we would substitute x equals 2 into one of the equations. It really doesn't matter which one. I'm just going to pick the second one, x plus 4y equals negative 2. So let's substitute 2 in for x. We have 2 plus 4y equals negative 2. Subtract 2 from each side. So we have 4y equals negative 4. Divide each side by 4. And y equals negative 1. So we get an ordered pair of 2, negative 1. Okay, and you notice we did add the equations together, and that is why it is sometimes known as the addition method. Now let's look at our second system of equations. We have 2x plus y equals negative 5, and 2x minus 5y equals 13. Now if we were to just add these together, you notice that neither the x's nor the y's would cancel. So what you need to do is decide which would you like to cancel, and it doesn't really matter whether you cancel the x's or the y's. Pick one or the other. Let's say that I decide I want to pick the y's. Okay, ask yourself, well, what would we need to have these these terms look like in order for them to cancel? And I'm thinking, well, if this first equation had a positive 5y, that would help to cancel it out with the second equation. Well, how could I get that? Well, I could do that by multiplying that first equation by 5. Now, the trick is you have to multiply every single term here on each side. So that's very important. So let's do that. If we say 5 times 2x, we get 10x. 5 times positive y gives you positive 5y, and 5 times negative 5 is negative 25. Now just write down your other equation. Underneath it, it's all lined up. And if you were to add these together, sure enough, the y's would cancel, and that's what we're going to do. Just add those two equations together so we get 12x. The positive 5y and negative 5y have canceled, and we have negative 25 plus 13, which gives us negative 12. Divide each side by 12, and we get that x is negative 1. Okay, so there's the first part of our ordered pair. Now, in order to find out what y is, we need to substitute x equals negative 1 into one of the equations. It's up to you which one you use. Let's say that I use the first one. So I'm going to substitute x equals negative 1. So I'm going to have 2 times negative 1 plus y equals negative 5. So I have negative 2 plus y equals negative 5. We want to add 2 to each side, and we have that y is negative 3. So our ordered pair is negative 1, comma, negative 3. Okay. And one thing I have not done, that I've neglected to do on both of these problems, is to check. That was one of the things I said we were going to do. So let's actually check this one. Okay. Remember, negative 1 is our x, negative 3 is our y. We check by plugging those values into each equation. So let's start with the first one. We have 2 times negative 1 plus negative 3. We want to know, does that equal negative 5? And sure enough, we have negative 2 plus negative 3, and that does indeed equal negative 5. So the first one checks out just fine. Let's take a look at the second one now. We're going to plug those values into the second equation. So I'm going to have 2 times negative 1 minus 5 times negative 3. We want to know, does that equal 13? And 2 times negative 1 is negative 2. Negative 5 times negative 3 is positive 15. And indeed, that does equal 13. Negative 2 plus 15 is 13. So I'm also going to leave it to you to go back and check the first one. So now let's go to the next page. Problem number 3 we are going to do in class. That's one of them that we will be working on when you first come into class. So let's move on to problem number 4. That was the one I wanted to look at. Okay. So let's say that we have this system of equations. We have 3x plus 3y equals 15, and negative 2x plus 3y equals negative 5. These equations do not cancel out as they are if we were to add them together. So we want to decide, do we want to cancel the x's or the y's and see if there's something we can multiply by to get the variables to cancel. Now I'm noticing the 3y's are identical. So if one of them was negative, I could get them to cancel out. So I'm going to pick just one of these equations and multiply by negative 1. Okay? So, and that means I multiply everything by negative 1. And when I do that, I end up with negative 3x minus 3y equals negative 15. The second equation remains the same. We haven't multiplied that by anything. We will have some cases where we do multiply both equations, but this is not one of them. Now let's add the equations together, and negative 3x minus 2x is negative 5x. Negative 3y and positive 3y, they cancel. And we have negative 5x equals negative 20. Now we can solve it. So divide each side by negative 5. And x equals positive 4. Now we want to solve, we need to solve for y by substituting x equals 4 into one of the equations. And it's up to you which one you want to use. Let's say we use the first one. It doesn't really matter. So we're going to have 3 times 4 plus 3y equals 15. So we have 12 plus 3y equals 15. Subtract 12 from each side. So we have 3y equals 3. Divide each side by 3. And y equals 1. So we have 4, comma 1. For our ordered pair, and I would like you to check that to verify the results. Now, I'm going to skip number 5. That's another one that we are going to do in class. And we are going to move on, actually, to the bottom of this page, to number 6, where we have negative 5x plus 2y equals 32. and 2x plus 3y equals 10 for our system. Now, right off we realize that neither the x's nor the y's will cancel if we add the equations together. So, let's decide what we want to cancel out. Whether you want to cancel x's or y's, and it's entirely up to you. Let's say I decide I'm going to cancel the x's. We want to think about what would we have to multiply these equations by, and we're going to have to multiply each equation. I notice that the x's are opposite signs, so we're in good shape on that. They would cancel as long as the values were the same, as long as the absolute values were the same. Since the signs are different, the terms would cancel if we could come up with a common value or common absolute value. So since the coefficient of x, of the x term in the second equation is 2, I'm going to multiply the first equation by 2. Since the coefficient of the x term in the first equation is -5, that's what I'm going to multiply the second equation by. Basically, I'm just switching these two values of -5 and 2, and that's what I'm multiplying by. So if I do that, my new equations will end up being 2 times -5x is -10x, 2 times 2y is 4y, and 2 times 32 is 64. Let's continue. We have -5 times 2x is -10x. And let's see, what did we do wrong here? Oh, we do not want to change those signs here, so we need to actually go back and fix that. I don't know what I was thinking there. Yeah, because we do want those signs to remain opposite. So if I go ahead and multiply through by 5, so if I go ahead and multiply through by 5 here, I've got 5 times 10, 5 times 2 is 10x, and 5 times 3y is 15y, and 5 times 10 is 50. Okay? Yeah, see, I wanted those signs to remain the same. So the -10x's and the -10x and the +10x are going to cancel out. And we have 4y plus 15y gives you 19y. And 64 and 50 gives you 114. Now, we want to get y alone. So we're going to divide everything by 19. And so we have 114 divided by 19. And so we want to know how many times does 19 go into 114. So let's start off trying 6. 6 times 9 is 54. 6 times 1 is 6, and 5 is 11. So sure enough, it goes in 6 times. So y is 6. Now let's go ahead and, since we know what y is, we want to find out what x is. We're going to substitute that value of y equals 6 into one of the equations. It doesn't matter which one. I'm going to choose the second one. 2x plus 3y equals 10. So we have 2x plus 3 times 6 equals 10. So we have 2x plus 18 equals 10. Subtract 18 from each side. And I have 2x equals -8. Divide each side by 2. And x equals -4. And so our ordered pair ends up being -4, 6. And if you notice, there are some more problems listed on your outline. Those are what we're going to be working on when you come into class for the next class. Thank you.